Hello everyone. Today we're going to talk about disaster recovery planning. And after you complete this topic, you should understand current disaster recovery strategies specifically for cloud environments. You should have a better understanding of how to estimate the cost of downtime. There are some intangible costs associated with downtime, and that's whether it's a man-made disaster, natural disaster, or whatever, hardware failure, any of those kinds of issues. There is a cost associated with that. You'll also understand disaster recovery for the different models that we've been talking about: infrastructure as a service, software as a service, and platform as a service. Then we'll talk about backup and restore methods, backup and recovery, some people refer to them as. We will talk about 4 methods of backup and recovery. As we know, there are all kinds of failures. They come in all flavors, all shapes and sizes. Sometimes it could be caused by a web server crashing. If the web server goes down, you have more than one web server. Redundancy is going to be key throughout this chapter. If you have redundant servers, then the one server that has crashed will be picked up, the load will be picked up by the other web servers, and usually that is transparent to the user, so there may be a little bit of a delay, but there is no noticeable downtime that the users can detect. Now, if a database crashes, which you never want a database to crash in the first place, but if there is a database crash, there has to be some rigorous backup and recovery strategies in place in order to prevent any loss of data in the database. This is particularly true for financial institutions. Then if the entire data center fails, usually if there's a data center failure, there's some sort of a catastrophic event that has occurred, a hurricane, flood, natural disaster of some sort that has brought the entire data center down. But if you have a disaster recovery solution, a plan in place, then the business can continue to function. If there is no design in place, a disaster recovery design, then that can shut a business down and bring the business to its knees. All right, the cost of downtime. As I mentioned earlier, there are some quantifiable costs that you can actually calculate. There are some intangible costs, and there are some variables that you need to understand. And if you can look at those variables and put a number on those variables, associate a number with the variable or a value, then you can use it to calculate things like lost man hours, lost workstation hours. We used to track those kinds of stats when I worked for the Boeing company. We would look at the lost man hours associated with a system being down or a workstation being down even. There are some definite costs associated with that. For one thing, you have employees who are not doing their jobs, and they're still on the clock. So the cost of the employee who's not being productive, plus the cost of repairing the equipment, plus the cost of any impact that it'll cause to the business itself. There are a lot of costs that can be factored in. So anyway, the first of these variables is the recovery time objective, RTO. That is the time within which the business requires that the service must be back up and running. Now, these variables, you will typically find them in a service level agreement with a cloud vendor. They will have a recovery time objective that says we cannot allow this business to be down for any longer than X number of minutes or hours or whatever the variable is. But it's a number that you can associate it with. This is how long we can stand to be down. And usually that number is very low. The recovery point objective, the amount of time it takes, the amount of time in which data loss can be tolerated. Usually that's a 0 if you're talking about a financial institution. Now, if you're talking about a social media company like Facebook, YouTube, or something along those lines, then the recovery is a little bit different than if you're talking about an e-commerce website or a bank or something along those lines. Of course, they cannot stand any data loss. Financial transactions typically will have a zero or near zero tolerance. They cannot afford to lose any data. And then there's a legal liability associated with losing data. If you lose somebody's data, then there's a cost associated with that. And as we have discussed with the Equifax situation, they are going to be held liable for putting their users' personal information in jeopardy. The value of recovery, a measurement of how much it is worth for the company to mitigate disaster situations. How much are you willing to pay to make sure that your services, your company is up and running even if there is a disaster? The value of recovery, that typically means you're going to spend money on redundant hardware, redundant networks, redundant solutions so that you don't have to have downtime. You don't need any downtime. You cannot stand any downtime, and so you pay the cost to make sure you have duplicate everything to prevent any downtime. Critical systems that have to be running 24/7, 365 will pay some money in order to keep the systems up and running. They'll have redundant hardware, redundant everything. So these variables, recovery time objective, the recovery point objective, and the value of the recovery should be factored for every component of a cloud architecture. And if you remember, we talked last week, there's the user layer of the cloud stack, there's the application layer of the cloud stack, the application stack itself, and the infrastructure. There's 4 different components. Each one of those has different functions and different services that are provided, and each one of those has to be up and running if you're talking about a cloud environment. All right, so here are the different models. We'll start with infrastructure as a service. If you recall, infrastructure as a service, the cloud provider was responsible for the bottom layer, which was the infrastructure, and the consumer, the business, the cloud service consumer or the business was responsible for the application stack, the application itself, and for the user layer. I'll throw that out there as well. So cloud providers, infrastructure as a service, cloud providers such as Amazon Web Services or Rackspace, they have had their share of outages over the years, but the smart companies that do this for a living, like Amazon, they have some built-in redundancy across multiple zones so they can maintain uptime regardless of where or when the outage occurs. So if you have redundancy built in, then an outage is going to simply shift the services to a different location, to a different zone, if you will, but the services will continue to run and the business will continue to operate. The cost and the complexity of cross-region redundancy has to be balanced with the value of the recovery, those 3 objectives: value of recovery, recovery time objective, and recovery point objective that has been established by the business. When they mention cloud agnostic, they are simply saying you don't want to be tied to a specific cloud environment. Rather, you want to avoid using proprietary application programming interfaces. You don't want to use APIs that have been developed in-house, APIs that don't function they don't play well with other components and things like that. You want to avoid those. You want to make sure that your cloud environment is as generic as possible. And the way you do that is you use a large selection of APIs that can be leveraged so you can build applications quickly and focus on getting the systems back up and running and solving business problems. If you're going with a proprietary API, that makes it a little more tough. If you go with generic off-the-shelf APIs, there's lots of them available. If you go that route, then you have more flexibility. Otherwise, you're painting yourself into a corner. All right, so if we're talking platform as a service, you have the option of public or private platform as a service. If you go with public platform as a service, the entire platform, which includes the application stack and the infrastructure, is the responsibility of the cloud service provider. I will refer back to those diagrams that we looked at in the last chapter, which showed that the user and the application was responsibility of the consumer, and the infrastructure and the application stack were the responsibility of the provider. And so if you're going with a public platform as a service, the cloud service consumer is going to be at the mercy of the platform as a service vendor and their disaster recovery plan. Hopefully they have a disaster recovery plan, but you are putting your destiny in the hands of the vendor when that happens. The best strategy: leverage a platform as a service vendor or provider that allows the platform as a service to run in any data center, regardless of whether it's on premises. Remember, you can have this running on your own premises or in a public cloud. So you rely upon the service level agreement to state who's responsible in the event of a disaster, and it's very clear if the vendor is responsible that they have a plan that is acceptable in case something does happen. And we know that disasters have been a little more common, a little more frequent lately, and hopefully the disaster recovery plans are more robust in order to accommodate the need and the demand. Now, with software as a service, such as Enforce Cloud Suite or CSI, the cloud service consumer, the customer, is dependent on the provider to manage the physical data center. In fact, if you remember, that diagram shows the infrastructure, the application stack, and the application itself are all the responsibility of the software as a service vendor. And so there is something called a software escrow, which allows the some funds to be set aside to protect the buyer, to protect the business or the customer if the vendor goes out of business or he, for whatever reason, severs the existing contract. The escrow, just like in real estate, will hold the vendor's intellectual property in an independent third-party holding area where it can be released to the buyer, to the customer, if the vendor goes sideways, the vendor goes out of business, whatever reason. The escrow can then protect the company from losing the data, because now you have basically ownership of the data through that third party that's holding the escrow for you. In some cases, it's recommended to use two different vendors, two different software as a service vendors. One goes down, the other one is still functioning. Also, it's a good idea to get data extracts from the vendor and keep those extracts. Even if you don't need them, you can archive them. You keep them for emergency purposes. It's kind of like insurance. If you know you have the data extracted in a safe place, no matter what happens with the vendor, you are protected. It's kind of like having backup. Basically, it is a sort of backup. Now, speaking of backups, in this week's reading, we talked about 4 common strategies, recovery strategies, for leveraging a physical or virtual data center, a secondary data center, to protect against disasters. So if the primary data center goes down, you've got a backup secondary, either physical or virtual system in place that can continue to function. Most companies do one or both or all of these strategies. So you have the classic backup and restore method, which we'll talk about here in a minute. You have active passive cold standby server. You can have an active passive warm standby server, or you can have an active hot. The active hot is simply a duplicate server that's running. In case one's down, the other one is up. So we're going to talk about these. Classic backup and restore. There's daily full backups, and then incremental backups are created and stored to a disk provided by the cloud vendor. The backups are copied to the secondary data center and possibly to a third-party vendor just to be safe. The database goes down, it's corrupt, or some kind of failure occurs, you can restore the last full backup and then apply the latest incremental backups in sequence so that you can recreate the data and get it back to a specific point in time. The recovery time objective for this is going to be long. It's going to take a while to restore from a full backup and then apply the incremental backups. That's going to take a while. Databases cannot be brought back online until all the relevant backups have been restored and all the quality of the data has been verified. So that's going to take a little bit of time. So if you have a short recovery time objective, then the classic backup and restore method probably will not work for companies that need to be up and running and can't afford any downtime. So here's a diagram which shows that you have your main data center over here. This is the main data center with your web layer, also known as the presentation layer. If you remember back to when we talked about architectures in Chapter 2. You've got the presentation layer with the web servers and web system, web graphical user interface and things like that. Then you have the business layer where you have an application programming interface or the middleware. And then you have the database at the storage layer. Those three layers are very familiar to us. You also have full and incremental backups in the secondary data center, which is usually located somewhere else. So let's say we lose the database. We lose the database here, and database goes down. Then you go with the full backup, and then you restore the incremental backups in sequence until you get the data recovered. This is classic backup and recovery method, but again, this is going to take some time. So if you've got a short recovery time objective, this method is probably not going to be the one. Then, as an alternative, you have active passive cold. The term cold simply means that you have redundant servers, but they're not on or running. You have them on standby, and if you need them, then you can bring them up. But what happens is you keep a set of scripts that are ready to be executed. The scripts give the configuration and the provisioning of the servers. Is configured exactly the same as the resources that are running at the primary data center. So you run the scripts, which gets the configuration back to where it should be. And then you can provision all of the web servers, application servers, everything in a duplicate environment in a secondary data center that is not running. So that's why it's referred to as cold, because it's not running. It's just in standby mode, waiting in case there is some sort of a disaster or some sort of an issue. The active passive cold approach, ideal if you have a high recovery time objective, which means when the RTO for an outage is less than a few minutes, active passive cold, like the other method we just talked about, is not going to be acceptable. It's going to take a while to get the new, to run the script, to get the new servers running on with the new provisioning, and so you're going to have some downtime associated with active passive cold. here's what it looks like. So you lose the database, just like we did in the other example. But then you run your scripts, you restore from backup. Your resources then are on the new master, because we run our scripts and put everything that was there looks exactly the same. The web server is configured exactly as it was before. The middleware is configured as it was. The database is restored from backup, as the arrows indicate here. So you still have to restore from backup, full, and then the incrementals on top of it. So it's going to take a little time. Plus, you've got to run the scripts too. So there's some time associated with this method. You can have something called an active passive warm, which means the database is always on and it's always in sync, because the database servers are always running. Usually you can take advantage of the fact that you have this additional database that's running, and you can use it for running reports. You can use it for doing some business analytics and things like that. So you can keep a separate copy of the database, improve the overall efficiency of the transaction processing database, and still have the functionality of the other database because it is running. This is ideal if you're running a live in-sync database at a different location. Then it will speed up your recovery time and minimize the recovery time. Then you can have active hot, which basically means you have two separate systems, duplicates that are running, fully redundant data centers running at all times. This is when failure is not an option, and you cannot have any downtime. In most cases, a complete failure of one data center will not cause any downtime because you have another system that's already in place with replication. So when a transaction happens on the master database, that transaction is transferred to the slave server. So they are always in sync with the master-slave replication. So if the primary data center fails, second data center becomes the new master, and vice versa. Once the primary system comes back up, you can switch them back. And so you can use replication to make sure you have two duplicate sets of data at any given time. Active, hot. If you cannot stand any downtime whatsoever, and failure is not an option, then active, hot is your solution. Of course, it is very expensive because you got two of everything, but the trade-off is you never have to worry about downtime. That's what this one looks like. So you lose the entire data center, you lose this one, you got this one that's ready to go, always in sync, always with the same exact duplicate information, because you're constantly synchronizing, you're constantly replicating, so you don't have to worry about any downtime at all because the data is already there and it's always there. So in summary, disaster recovery plans, if we know nothing else, we know that global warming has increased the frequency of hurricanes and floods and natural disasters and fires. There are all kinds of things that happen to data centers, even in cloud environments. And so making sure you have a plan in place, understanding the nature of the data that's being stored in the cloud, understanding the nature of the business and whether or not they can stand downtime. If you are an e-commerce retail company, you cannot stand downtime because you will lose business. You're not you're not operating to lose business, to lose money. You're trying to make money. So you spend some money and you get the redundancy in place so that you don't have to suffer any downtime, any outages at all. And if you're a critical system like a hospital or a 911 system or any systems that have to be running all the time, you make sure you have the redundancy in place so that you don't have to worry about what happens if. You know what happens. If your system, if this system goes down, you know that the secondary system is right there to take up the slack. In order to implement the appropriate strategy, you have to understand the recovery time objective, the recovery point objective, and the value of the recovery. And again, if you cannot stand any downtime, you understand the value of the recovery and you pay for the redundancy. You just simply pay the cost. If it's critical to understand the disaster recovery model, which it is, it's also critical to understand the disaster recovery architectures in the cloud stack and what the function of each component is. Some of the things that we've been talking about earlier. If you're developing a plan, it's important to understand the architecture. The greater the risk, the more likely the company is going to want to mitigate that risk. And we talked about some risk mitigation strategies and some risk tolerance approaches. Risk tolerance usually will drive the cloud service and deployment decisions, including the disaster recovery plans. Please let me know if you have any questions.